Connecting an uninterruptible power supply to a supply receptacle and then to a distribution panel using cords and plugs is a violation of the National Electrical Code, specifically NEC 400.8.1. This section of the code is very clear in stating that flexible cords shall not be used as a substitute for the fixed wiring of a structure. The intention of this code is to ensure safety and prevent the use of flexible cords in place of permanent wiring methods that are designed to handle the electrical demands and provide long-term reliability within a building's electrical system. The proposal to use cords to supply power from the UPS to a distribution panel directly contravenes this requirement because the distribution panel is part of the permanent building wiring infrastructure. In a typical electrical installation, the distribution panel receives power from the utility service through permanent wiring methods, such as conduit containing individual conductors or cable assemblies that are specifically designed and installed for this purpose. These permanent wiring methods are selected to meet the specific electrical load requirements of the circuits that the distribution panel serves, ensuring that the wiring can safely handle the anticipated current without overheating or causing other electrical hazards. The use of flexible cords to connect the UPS to the distribution panel introduces several potential issues. Firstly, flexible cords are not designed to be used as a permanent wiring solution. They are typically intended for temporary connections or for powering portable equipment. The insulation and construction of flexible cords are not as robust as those of permanent wiring methods, making them more susceptible to damage from physical stress, abrasion, and environmental factors. Over time, this damage can lead to insulation breakdown, short circuits, and even electrical fires. Secondly, flexible cords may not have the appropriate ampacity for the intended application. Ampacity refers to the current carrying capacity of a conductor, and it is essential that the wiring used in an electrical circuit is sized appropriately to handle the expected current draw. If the flexible cords used to connect the UPS to the distribution panel are not rated for the ampacity of the circuit, they may overheat, leading to insulation damage and potentially causing a fire. This is a particularly important consideration in UPS installations, as the UPS may be required to provide backup power to critical loads during a power outage, and the wiring must be able to handle the full load current without any issues. Thirdly, the use of flexible cords in this manner can create a tripping hazard. Cords that are run across floors or along walls can be easily damaged or become entangled, increasing the risk of someone tripping and falling. This is especially concerning in commercial or industrial environments where there may be a high volume of foot traffic. In addition to the safety concerns, using flexible cords as a substitute for permanent wiring can also create problems with the overall reliability of the electrical system. Flexible cords are more prone to damage and degradation than permanent wiring methods, which means that they may require more frequent maintenance and replacement. This can lead to downtime and increased costs over the long term. To ensure a safe and reliable UPS installation, it is essential to use permanent wiring methods that comply with the National Electrical Code and other applicable standards. This typically involves using conduit to protect the wiring and selecting conductors that are appropriately sized for the ampacity of the circuit. The conduit should be securely fastened to the building structure, and the conductors should be properly terminated at both ends. By following these best practices, you can ensure that the UPS is installed in a manner that is safe, reliable, and compliant with all applicable regulations. It's important to consider that electrical codes and regulations are in place to protect people and property from electrical hazards. Adhering to these codes is not just a matter of compliance, it is a matter of safety. When planning an electrical installation, it is always best to consult with a qualified electrician or electrical engineer who can ensure that the work is done in accordance with all applicable codes and standards. In the context of UPS systems, proper installation is even more critical, as these systems are often used to provide backup power to essential equipment and services. A properly installed UPS can help to prevent downtime, protect valuable equipment, and even save lives. So, while it may be tempting to cut corners or use temporary solutions, it is always best to invest in a proper electrical installation that will provide long-term reliability and safety. In the specific scenario that was described, the correct approach would be to use permanent wiring methods such as conduit and appropriate gauge wires to connect the UPS to both the supply receptacle and the distribution panel. This ensures that the installation meets the requirements of NEC 400.8 and provides a safe and reliable electrical connection. This type of permanent wiring is designed to handle the continuous load and environmental conditions, unlike flexible cords which are intended for temporary use and are more susceptible to damage and wear. When dealing with electrical installations, it is always best to err on the side of caution and follow the established codes and standards. This will help to ensure that the installation is safe, reliable, and compliant with all applicable regulations. In this case, the National Electrical Code provides clear guidance on the proper use of flexible cords, and it is essential to follow this guidance to avoid potential hazards. Furthermore, it is worth noting that the ampacity requirements of the circuit must be carefully considered when selecting the appropriate wiring method. The ampacity of the wiring must be sufficient to handle the maximum current that the circuit is expected to carry, and it must also be derated to account for factors such as ambient temperature and the number of conductors in a conduit. Using wiring that is undersized for the application can lead to overheating, insulation damage, and potentially a fire. For example, if the UPS is designed to provide backup power to a critical load that draws 20 amps, the wiring used to connect the UPS to the distribution panel must be rated for at least 20 amps, and it may need to be derated to account for other factors. The specific ampacity requirements will depend on the size and type of the conductors used, as well as the installation conditions. In addition to the ampacity requirements, it is also important to consider the voltage drop in the circuit. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, it is important to use wiring that is appropriately sized for the length of the circuit and the expected current draw. The National Electrical Code provides guidelines for calculating voltage drop and selecting the appropriate wiring size. It is also worth noting that the use of flexible cords in place of permanent wiring can create confusion for future electricians or technicians who may need to work on the electrical system. When permanent wiring methods are used, the wiring is typically labeled and documented in a clear and consistent manner. This makes it easy for electricians to trace circuits, identify components, and perform maintenance or repairs. However, when flexible cords are used in place of permanent wiring, the wiring may not be labeled or documented properly, which can make it difficult to understand the electrical system and perform work safely. In addition, flexible cords may be more easily damaged or disconnected, which can lead to unexpected power outages or other electrical problems. To avoid these issues, it is always best to use permanent wiring methods that are properly labeled and documented. This will help to ensure that the electrical system is safe, reliable, and easy to maintain. Proper installation according to NEC 400.8 involves using permanent wiring such as conduit and cable should be used to connect the UPS to the supply receptacle and distribution panel. This ensures a safe and reliable electrical connection. The selection of conduit type depends on the environment. For example, in a dry indoor location, electrical metallic tubing, abbreviated as EMT, might be suitable. In a wet or corrosive environment, rigid metal conduit or PVC conduit may be required. The choice of cable depends on the specific application and the requirements of the National Electrical Code. For example, non-metallic sheath cable, often called NM cable, is commonly used in residential wiring, but it is not permitted in some commercial or industrial applications. Armored cable, frequently referred to as AC cable, or metal-clad cable, known as MC cable, may be used in these situations. Firstly, planning and preparation is important. Before starting any electrical work, it is crucial to plan the installation carefully and ensure that you have all of the necessary materials and tools. This includes selecting the appropriate type and size of conduit, cable, and connectors, as well as gathering the necessary tools for cutting, bending, and installing the conduit and cable. It is also important to review the National Electrical Code and any other applicable codes or standards to ensure that you are familiar with the requirements for the installation. Secondly, conduit installation, including measuring, cutting, and bending. If conduit is used, the first step is to measure and cut the conduit to the appropriate length. This can be done using a hacksaw, a pipe cutter, or a specialized conduit cutting tool. The conduit should be cut squarely and endeavored to remove any sharp edges that could damage the conductors. If bends are required in the conduit run, they can be made using a conduit bender. It is important to make smooth, consistent bends that do not kink or damage the conduit. The radius of the bend should be large enough to allow the conductors to be easily pulled through the conduit. Thirdly, conductor selection and installation. Once the conduit is installed, the next step is to select and install the conductors. The conductors should be sized appropriately for the ampacity of the circuit, and they should be insulated with a material that is suitable for the application. The conductors should be pulled through the conduit using a fish tape or other pulling device. It is important to avoid damaging the conductors during the pulling process. Fourthly, termination and connection. After the conductors are pulled through the conduit, they must be terminated at the appropriate devices, such as receptacles, switches, or circuit breakers. The termination should be made using approved connectors and methods. It is important to ensure that the connections are tight and secure to prevent overheating and electrical hazards. Fifthly, inspection and testing. Once the installation is complete, it should be inspected and tested to ensure that it meets the requirements of the National Electrical Code and any other applicable codes or standards. This may involve performing a continuity test to verify that the conductors are properly connected, an insulation resistance test to verify that the insulation is not damaged, and a voltage test to verify that the voltage is correct. By following these steps and adhering to the National Electrical Code and other applicable standards, you can ensure that the UPS is installed in a manner that is safe, reliable, and compliant with all applicable regulations. Remember, working with electricity can be dangerous, and it is always best to consult with a qualified electrician or electrical engineer if you are not comfortable performing the work yourself. The NEC, or National Electrical Code, provides specific guidelines for the installation of electrical systems. For example, NEC section 400.8 addresses securing and supporting wiring. This section requires that wiring be securely fastened to the building structure to prevent it from becoming damaged or creating a hazard. The specific requirements for securing and supporting wiring vary depending on the type of wiring, the size of the wiring, and the location of the wiring. Another relevant NEC section is 310.15, which covers the ampacity of conductors. This section provides detailed information on how to determine the appropriate size of conductors for a given circuit. The ampacity of a conductor is the maximum current that it can carry without overheating. The NEC provides tables and formulas for calculating the ampacity of conductors based on factors such as the type of insulation, the ambient temperature, and the number of conductors in a raceway. NEC Article 400 specifically covers flexible cords and cables, outlining their permitted uses and limitations. This article reinforces the prohibition of using flexible cords as a substitute for permanent wiring and provides guidelines for their proper application in temporary or specific situations. For instance, flexible cords can be used for connecting portable lamps or appliances but not for the fixed wiring of a building. NEC Article 500 addresses hazardous locations, which are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dust. If the UPS is located in a hazardous location, it must be installed in accordance with the requirements of Article 500. This may involve using explosion-proof equipment and wiring methods. Ensuring a safe UPS installation also involves proper grounding. Grounding provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The NEC provides detailed requirements for grounding electrical systems, and it is important to follow these requirements carefully. For example, NEC Section 250.4 requires that all electrical equipment be properly grounded. This can be achieved by connecting the equipment to a grounding electrode, such as a ground rod or a metal water pipe. When installing a UPS, it is also important to consider the potential for electromagnetic interference or EMI. EMI can disrupt the operation of electronic equipment and can even cause damage. To minimize EMI, it is important to use shielded cables and to keep the UPS away from other sources of EMI, such as motors and transformers. In addition, it is important to properly ground the UPS and all connected equipment. Also, make sure that you have a surge protection, because surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD work by diverting the surge current to ground, which prevents it from damaging the equipment. The NEC requires that SPD be installed in certain locations, such as at the service entrance of a building. In summary, connecting a UPS to a supply receptacle and a distribution panel using cords and plugs violates NEC 400.8, which prohibits flexible cords from being used as a substitute for fixed wiring. To ensure a safe and code-compliant installation, use permanent wiring methods, consult the NEC for specific requirements, and engage a qualified electrician if needed.